Okay, so spellwork question. I'm gonna pull a stick. Anna, what's the opposite of addition? What undoes addition?
Subtraction.
Subtraction. So if I have a number and I don't know what that number is, and I add 2 to it, I'm gonna undo that by subtracting 2, right? So I subtract that 2, and I'm just left with the numbers, right? June, what undoes multiplication? Division. So if I have a number and I've multiplied something by it, I undo that with division, and that goes away. Okay? Who can remember what it means when I square something? If I have 5 squared, what does that mean in English or in math? Trisha, oh my gosh, you were very excited.
Don't we times it?
Times it by what? By 2?
No,
Is it by 2? What is it, Maddie?
it's by itself. You
Times-
times 5 by 5.
How many times?
2.
Well, I mean, 1 time multiplying it, but it
Yeah.
shows up
Twice.
twice. And what's 5 times 5?
25.
25. Okay. Today we are going to learn how to undo a squaring. So if this is our symbol. It's called a radical, and it's totally radical. Okay. This number is a little shell that we use to indicate what root we're taking. Okay. If there is nothing there, then it is a invisible 2. So if there's nothing there, we assume it's 2. If there is a number there, tomorrow we'll learn about cube roots. If there's a 3 there are also 4th roots and 45th roots and 145th roots. Will we be doing 145th roots in this class?
No.
No, we will not. Can they be done?
Yes.
Actually, yes, they can, but we will not. We will only be doing square roots and cube roots in this class. Okay, so today we're only doing square roots. So if I have the square root of 25, I am undoing a squaring. I am saying, what number squared equals 25?
5.
Well, what number squared equals 25?
5.
So the square root of 25
It's 5.
is 5. Please get that? And there are numbers, 25 is one of them, that are perfect squares, where life is beautiful. Let's do another one. What number multiplied by itself is 144?
12.
Maddie, what is it?
12.
12. 12 times 12 is 144. So the square root of 144 is 12. What if I give you one that you don't know? What about the square root of 225? Rye, do you know it? It's 15, but what if you didn't? What if you weren't Rye? And Mrs. Barlow, I think we're the only two ones in the room who knew that. Cheyenne might have, didn't raise her hand. Did you know? Did you? You're kind of thinking of it. Okay, so what if you're looking at that? Let me get one that's big.
Juan Rodriguez, will you come to the office, please? Juan Rodriguez.
One that probably nobody's gonna know. You ready? No, you're not. Well, ish. Okay. We're not using the square root button on your calculator today, though. We're gonna do all these by hand. So what if we have the square root of 441? Do any of you know the square root of 141 just off the top of your head?
17.
Okay, so Ashley says to herself, 17 is plausible. 17. No, is it going to be 17? No, because 7 times 7 is 49, so that would end in a 9. But it would give us a good starting point. So here's what I'm allowing you to do. You can use a calculator and go 17 times 17. Well, that's 289, which is way too low. So we need a number that is bigger than 17? Maddie,
18. So 18.
18. But 17 is
Oh, wait.
like
hold on.
hundreds too low.
20,
Should we do something bigger?
28.
24! Let's try 24. So 24 times 24 is 576. We overshot it.
23. 21.
So now I want you to start. So Ashley's tossing out numbers, which is a fabulous thing for Ashley to be doing. But now I want us to start thinking. Do we have a number that would end in 1 if we multiplied it by itself? Blue, what do you think? Let's try 21. Maddie, I know you're raising your hand, but I'm going to let other people have a turn. So 21 times 21. 1 times 1 is 1. And that is 21. Oh, these should be squareds. Is 441. So 21 squared is, so the square root of 441 is indeed 21. Was 17 a bad starting guess? No, it was not. She got decently close. Then we went up to 24, which was, we overshot, so we knew it was somewhere in between the two. That's what you're going to be doing today. Except I've got some wrenches I'm going to throw in. These have all been really pretty numbers, okay? But I'm going to teach you a word today for numbers that are really not, okay? Who knows what a ratio is? What's a ratio? Okay, Ann, what do you think of ratios? She's looking at this 6th grade word wall. It's there. A ratio is sitting right there on the 6th grade word wall. You guys are lucky I teach 6th grade.
A comparison of 2 numbers.
A comparison of 2 numbers.
I don't like ratios.
You don't like
I
ratios?
don't like ratios.
You guys, ratios are just fractions. Ratios are just fractions. Okay? So if I have a number, I am having a fart of brain.
You're having a fart of a brain.
I couldn't remember if it still had the O. Okay, O-N-A-L. That is not the word rational, even though it is spelled rational, okay? So it's spelled rational, but the word is rational, okay? If you guys have ever heard the, like, oh my gosh, be rational. It's not the same meaning. Oh, I need to get a shirt. There's a shirt. I need this for Christmas. Where there's 2 numbers that are fighting and pi is talking to square root of -1. And he says, be real. And -1 says, be rational. Anyway, pi is not a rational number. Rational means you can have rational numbers. What do you guys think would be true of rational numbers, knowing that a ratio is a fraction? What do you think, Tan? They can be expressed as fractions. So, can 4 be expressed as a fraction? Yeah, it's just 4 over 1, right? Can 0.5 be expressed as a fraction? Yes, it's just 1/2. What about 0.3 that goes on forever and ever and ever? Can that be expressed as a fraction?
Yes.
What fraction is it? 1/3. Fracture decimals that repeat can be expressed as fractions. If you have 0.7 that goes on forever, that is 7/9. Actually, any single number that goes on forever can be put over 9. So 0.3 forever is 3 over 9, which reduces to 1/3. It's just your nifty thing. So 5/9 is 0.5 forever, okay? But there are numbers that go on forever and do not repeat. Pi is one of them. We'll put that over here. Pi, as far as we know, and they have, I think, calculated pi out to the billionths of decimal places. They have not found a place where pi repeats. There's also e, which is the base of the natural log, which you'll become friends with in Algebra 2, I believe. We won't get into it too much today. There's also the square roots of almost every number number that's not a perfect square. These go on forever and they do not repeat. If these are rational, what are these called?
Unrational.
Non-rational, that's a good, there's different prefixes that mean not. There's non, it's not the one we're using today. Guess is on the one we are using, Shaylee.
Unrational.
Unrational, noble effort, but not irrational. These are irrational numbers. Are we going to have irrational numbers in our assignment today?
Probably.
Do I expect you to find these decimal places that go forever?
No.
How long will that take you?
Forever.
Literally forever. I don't expect that. How many decimal places do I want?
2.
Two. We're gonna stop at 2. But you're gonna I think you're gonna have you tell me that it's irrational. So what do we do for numbers that are not perfect squares? Give me a number.
5, 9, 10. I don't know.
Let's just do
15.
Let's just do 5. Let's just do 5. We could do 5,910, but let's just do 5. We know that the square root of 25 is 5, but what about the square root of
5 itself.
5? Okay, so let's think about this. Excuse me. I just swallowed my spit down the wrong tube. I'm not sick, I just don't know how to swallow. Okay, so where's a good starting place? Because Ashley, when it was 400 whatever, she just shot out 17. We want to have a good starting point. What's a good starting point, Maddie?
2.5.
Why 2.5?
Because I was doing addition.
Okay, well let's think about numbers that are perfect squares that are close to 5.
4.
Monica, what's a number that's a perfect square that's close to 5?
2 times
2 times 2 is 4. So we have 4. What's the number that's smaller than 5? What's the number on the other side of 5 that's a perfect square? 6 is not a perfect square. 8 is not a perfect square. 7 is prime.
9. 10.
9 is a perfect square. 9 is 3 times 3. You guys would do well to remember your multiplication. Trisha, your hand has been up for a long time.
Sorry.
Did you have something?
No, I don't think so.
Oh, did you just raise your hand and forget to bring it down?
Yeah.
Does it get tired? Anyway, so we want a number that's somewhere between 4 and 9. Now, is 5 closer to 4 or is 5 closer to 9?
4.
4. And 4 is 2 times 2. And 9 is 3 times 3. So we know it's going to be closer to 2 than it is to 3, right? So it's not going to be like 2.9 because that'll put it up in the 8s. And it's not going to be, so Maddie wanted 2.5. Do you still want 2.5, Maddie?
No.
What do you want?
1.5.
But that's smaller. That's going to be, if we do 1.5, that'll be smaller than 4. I know it's going to be bigger than 2. It's going to be smaller than 3. Because 5 is bigger than 4.
So yeah, 2.5.
2.5, what do you think, Ann?
2.3.
Do you do 2.3? Yeah. Let's do 2.3. So it's 2.3 times 2.3. We want to get as close as we can. So we get 5.29. I think we can get closer. What do you think, Blue? What if we just do 2.1?
That's what I was going to
Let's
say.
get really small because 5 is not that much bigger than 4. What happens when we have 2.1 times 2.1? Oh, see, now we get 4.41.
2.2.
So now we're the other way. So Blue, what did you suggest? 2.25. Let's try it. Ooh, 5.06.
Wait,
So that second number is good, but the 5 is a little bit high. Do you see that? Because we got that 0. Let's see if we can get that 6 a little smaller.
2.2.
2.23? Well, what is 2.2? 4.84. We're low.
2.23.
2.23. Ooh. So I'm thinking 2.24 is going to be our best bet. 5.02. Okay. Here's the deal though. How many decimal places do I want you to go to?
2.
Could you go to 2.235 and get closer?
Yeah.
How many decimal places are we out now? We're out 3. Do you need to get that tight?
No.
Do I want you to do this till tomorrow?
No.
No, I don't. This is really close. This is really close. Honestly, I'd probably take either of those answers and be fine with it. Just get close. These are irrational numbers. They're going to go on forever, which means you could literally do this forever.
Oh, that's
Do I want you to do this forever?
No.
No. Now let's talk about some things you can't do. Okay? What number multiplied by itself equals negative 25? Trisha!
5.
But 5 times 5 is positive 25.
Negative.
Negative 5. Negative 5 times negative 5. Okay, I've got 5 times 5 is 25. And a negative times a negative is a...
Positive.
No, negative 5 times 5.
But that's not times itself. That's not squaring it. Negative 5 and 5 aren't the same number. Would you guys like to see what happens when I put negative 25 on my calculator and try to do the square root?
Oh gosh.
It's not going to work.
It says error. Why does it say error?
Because it's not possible.
Because there are no real numbers that work for this. There are numbers that are not real, but today, in 8th grade, we only care about the real numbers. So what do I say? What do you do? You're asked this question. What's the square root of negative 25?
There's nothing.
Spheres.
There is no real
Numbers.
doesn't
Exist.
work.
Error.
Nope.
Nobody
Nope.
knows.
Nope.
Error.
Yep. Nothing. You can't. Tomorrow, maybe we can a little bit with something else. But today, it's fine. You guys look at me like you're gonna die. Math builds. Tomorrow we build. Tomorrow we'll have some negatives that are our friends. But today, no negatives for us. So, would you like me to do number 1 on your assignment? It says determine the positive square root of 81 if it exists. Why does it say the positive square root of 81?
Because the number's positive.
Because negative 5 times negative 5 equals positive 25. Does every number have a negative square root?
No.
Yeah.
Yeah. No.
Every number has a negative square root. We only want the positive ones today. So let's do with that one. We're going to do number 1 together. Get you guys started on your assignment. Okay, what is the positive? So I'm going to write it like this. Positive square root of 81. What number multiplied by itself is 81? Shaylee? 9. 9 times 9 equals 81. So the positive square root of 81 is 9. Right? Are they all going to be that pretty? They're not. Is that okay? Yeah, we can do this. It's not a super long assignment, so you guys can muscle through. And I'll be right back. Yeah. Bye. I say goodbye, and then I take forever to walk over here.